So hi everyone, welcome to my YouTube channel. You can see this is the experimental setup for the experiment on resistivity of a semiconductor. So in this experiment we have to determine the resistivity of the semiconductor at room temperature by two probe method. Apparatus required for this experiment are traveling microscope, ammeter, voltmeter, DC power supply or the battery, and connecting wires. Here is the semiconductor specimen, that is silicon we have used, and we can see the two probes. So we have to make the connections according to the given circuit diagram here. So here is the silicon semiconductor specimen where we have attached the two probes, and we have to connect the voltmeter to measure the voltage difference across these two probes. Then positive terminal of the emitter must be connected to the semiconductor specimen. Negative terminal must be connected to the positive terminal of the battery. Negative terminal of the battery must be connected to the silicon specimen. So here you can see the circuit connections has been made. The voltmeter, that is DMM, has been connected across the two probe to measure the potential difference across these two probes. So here we have to keep the first probe at a fixed position, and we have to change the position of the second probe, and we have to note down the traveling microscope reading each time. So you have to repeat the same procedure for 3 or 4 trials. Here horizontal scale you have to take to measure the distance of first probe and second probe, position of the first and second probe. So here you should note down the position of the first probe and second probe with the help of traveling microscope. You have to take here the horizontal scale reading of traveling microscope. So you should also know about the least count of the traveling microscope. You can calculate the total reading, that is what the position of the first probe, that is equal to MSR plus CVD into least count. Similarly, you should note down the position of the second probe by calculating total reading MSR plus CVD into least count of the traveling microscope. So first probe position is fixed, and second probe each time you are going to change. So here you have to note down the current and corresponding voltage. So each time you have to apply 2 ampere of current, and you have to note down the potential difference across the two probes with the help of DMM, digital multimeter. So you can take the variation of current, that is 2 milliampere, 2, 4, 6, 8, and like difference of 2 up to 10 milliampere. 5 readings you can take for the position of the first probe and second probe. Repeat the same procedure for the different position of the second probe. Note down the current and voltage reading. So here is the tabular column for this experiment. Position of the first probe is fixed for all the different trials. So position of second probe we have to change each time. So for first trial, if you are taking the position of the second probe, you should note down with the help of traveling microscope. So then you have to take the difference of the length between first probe and second probe, and simultaneously you should note down the current through the specimen in the ammeter, and voltage you should note down from the digital multimeter. So here you can see the readings of current and voltage for the position of the second probe for second trial. So position of first probe is fixed. So like that you have to take the 4 trial reading, the position of second probe, difference of length and current voltage readings. You take the reading. So for the first trial you should note down the current and voltage and use the LSF method to calculate the LSF parameter, slope, intercept, and you can plot the graph of current versus voltage. That must be straight line. So like that you have to draw the 4 graphs here for 4 trials, current versus voltage. So here are the LSF parameters, slope, intercept. So here one more thing you should note down here. After calculating the LSF parameter for all the tabular column, if once you get the slope for particular reading for the particular table, use that slope and intercept to calculate the x1 and y1 value. So x1 is given by x minimum minus small value, that is here the x minimum is what, the current, that is 2 milliampere. 2 milliampere you should write, and small value less than 2, that is 0.5 you can take. So it will be 1.5 10 to the power minus 3 x1. y1 that is mx1 plus c. Y equal to mx plus c formula you have to use. Slope you have calculated from LSF parameters, substitute that, and intercept also you have calculated, substitute, you will get the y1. So x2 similarly you have to calculate. x2 if you want to calculate maximum value plus small value, that is maximum is how much current here, 12 milliampere, small value 0.5, 12.5 milliampere. x2, y2 you can calculate using slope and intercept and value of x2. So here you should mention the value of x1 and y1 for all the 4 graphs. So here you come across the 4 tabular column for LSF method. Okay, and here are the graphs, 4 graphs you have to plot. So all must be straight line. For different position of the second probe, you have to plot the graph of current and voltage. Calculate the resistivity. You can calculate electrical conductivity, which is inversely proportional. So once you calculate the electrical resistivity and conductivity, you can write the result.